Hello, everyone. My name is Saed Hasan. I'm a PhD candidate at Technion-Haifa. You are welcome to a quick presentation related to the state of the art in BIM and construction tech integration for construction operations. Well, as we know, the construction cycle consists of 6 main stages, starting from programming, design, pre-construction, construction itself, operation, and demolition. So each stage has its own data input, processes, and output. However, it's a big challenge how to move the project from design status to as-built status. It's a challenge to transfer the product information into process information to achieve the product as designed with a planned time and assigned budget. So it's scheduling, cost, and quality assurance issues. In 2000, BARD set up the overall framework of the last general system as planning approach for in construction. But its manual approach in parallel BIM became more usable and valuable in construction industry, especially for scheduling and look-ahead planning production. Here a question raised up as, could BIM and construction tech be integrated for better and automated operation control approaches? So what work has been done related to this subject? What construction technologies have been used for what purposes? Technically, construction technologies could be used for data gathering from site to BIM, or it can be used also for information transfer from BIM to the site. Today, there are tens of technologies and innovations with different applications in construction field. These technologies known as construction tech. Computer vision and machine learning have been successfully used for construction work monitoring. Meanwhile, point cloud technology became easily applicable in wide range for as-built data collection, in addition to other technologies were used with valuable inputs into construction work. In fact, there are many applications, many success stories, as well as there are many limitations in this work. We reviewed the state of the art related to the subject. Problem finding, which review 76 research papers related to BIM and construction tech were selected and were selected after searching topics such as BIM for construction and operations control, BIM and BIM construction integration for optimal planning, such as construction tech and BIM integration. Much of the research found was published in Automation in Construction and similar journals and international conferences related to computing and construction. Some people use construction tech for automated site monitoring systems, field to BIM data gathering. Others use BIM for product and process information management. And in a few cases, construction tech have been used for product and process information transfer, BIM to field information transfer. Data collection and analysis, field survey of construction tech companies. Several startup construction tech companies are developing automated systems to support the construction cycle in different phases. There are many successful technology applications in data gathering, data monitoring, and visual data projection. In this work, we present 26 startup companies investigated. These companies have been reviewed in aspects of used technologies and functions. The companies were classified based on the functions of their solutions, such as scheduling, data gathering from site, information transfer to the site, etc. Moreover, the investigated startup companies have been reviewed referring to data collection and information output. Generally, most of the startup companies aim to improve construction control by providing accurate site progress monitoring, automated and accurate data measurement, crews and machines or resources on site tracking, space availability, construction, planning, and scheduling. It was also clear that some of the companies try to integrate BIM and automated technologies to automate the site work monitoring. However, this integration has limited support for construction production and planning process. Data collection field questionnaire. A field questionnaire was conducted with the construction staff, such as engineers, planners, construction managers, directors, QA, QC specialists, and others, to explore possible and current use of construction tech on site. The questionnaire consisted of 22 questions, which focus on the participants' current and most recent experiences with reference to the process itself, challenges, main impacts, advantages and disadvantages, technologies, purposes of the implementation of the construction technologies, achievements and workability, etc. 78 qualified participants from different countries, mainly GCC region, USA, Canada, Europe countries, China, India, Australia, and other countries. They filled out the questionnaire. 12% of the participants had a director position. Around 25 of them were senior managers, 30% were managers. It was clear that results found that 41% of the participants worked in planning and control department. Meanwhile, 27 worked in design and technical rules. 41 worked in site construction. 41 also worked in BIM and digital construction, while only 4% worked in machine learning and artificial intelligence. The collected answers showed that 69% of the participants confirmed that they use manual paper written reports through site visits for on-site data collection purpose. Meanwhile, 19% of them use personal data assessment for data gathering, such as tablet phones. Meanwhile, only 12% use an automated system for data collection using construction tech tools such as robots, laser scanners, cameras, sensors, and others. The participants' feedback shows that construction tech is still rarely used. 51% of survey participants had never used construction tech in construction work. Meanwhile, 49% of the participants confirmed that they were working or had worked in projects which implemented construction technologies to improve and control the construction processes in one form or another. This table shows the data analysis for received answers from 39 valid participants in the construction tech field. 46% use construction tech for data collection. 73% use them for information transfer, and 12% use specific technologies for data monitoring. Work extension lab experiment. We were able to design and develop a lab experiment to successfully integrate complex image processing system for field to BIM data gathering and BIM to field information transfer. So we're trying to check the ability of different used technologies for work progress road data gathering from site to the BIM, interpreting monitoring data to generate meaningful progress information, and also product and process information transfer from BIM to the site. This is the lab layout. It consists from the construction room, monitoring room, store, outside working area. The plan is to build 2 drywall partition. One of them represents toilet partition with full MEP and plumbing fixture. The BIM model up to LOD 400 is developed with the needed information. In addition to 4D BIM file was created. From the beginning, we defined the set of proposed technologies that we can use for data collection from site to BIM and information transfer from BIM to site. We successfully integrate laser scanning machine, projector, robot, Bluetooth sensors, video, cameras, mobiles, audio recorder, digital camera, 360-degree camera, and laser projection machine. So the construction work started as planned, as we see in this picture, and it also constructed as designed, as we see in this picture. And from this image to this image, there are tons of data captured and collected from the site. How? We use a video camera for 24/7 video recording. We use a view sonic projector for layout transformation onto work surface, and we can see how worker can use the marked layout and direct project it to the surface to fix and install some elements. We use robots for automated layout marking on the surface as per BIM information. Also, we use the laser projection machine to project full partition layout design up to 1 mm accuracy. We see in the picture here how the worker used the projected laser lines to fix and install the wall tiles. Also, we use a Trimble X7 scanning machine for weekly as-built BIM production. This has been made possible using the 3D scan data received as point cloud. The site work are then analyzed and reflected in the progress model. 360-degree camera were used to capture site progress from site to the BIM in daily basis. This helped to follow up the daily construction progress in reference to the BIM model. Bluetooth system also helps to track construction resources and get data in real time 24/7. This helps to measure work productivity, crews behavior, and time waste through the construction work. Also, all information related to the construction work have been managed via VisiLean platform, site progress, planning and task scheduling, assigning the construction constraints, materials and resources issues, and others. The recorded video data were labeled using MATLAB application. So the video data was used to provide ground truth database, what work has been done, what time, by whom, what tools have been used to do the work. By end of this experiment, we expect to achieve the result related to the capability of each used technology to define the micro event in construction work. Micro events means start time, end time, worker, trade, location zone, tool, activity, product, BIM part, material. We will be able to measure the accuracy of detected micro event based on ground truth database. So what if we use more than one technology to detect the micro events, such as Bluetooth and 360-degree camera, or Bluetooth and audio record? What if we use the captured images as well? The goal is to check the capability of building a framework model based on BIM and Construction-Tech to improve construction operations by supporting look-ahead planning and decision-making process. As a summary, automated technologies are rarely used to support automatic information transfer from BIM to workers using either augmented reality or projection of the information onto the work surface. There are no BIM Construction-Tech framework to integrate monitoring data collected to provide meaningful and comprehensive project status information, nor for direct delivery of product and process data to workers. Also, I would like to mention that this paperwork is a background part. The lab experiment is still in progress. Currently, we are at data processing stage. Accordingly, there is no conclusion part for the presented experiment work. And thank you so much. Thank you.